instruction. It consists of the machine instructions, and you can see it uses the registers and unnamed memory locations in order to store the variable, right? And it is much harder to understand by humans. Previously we understand this one. Now we are not able to, same code, maybe same code, but we are not able to understand this one, right? So this is not that much human readability, but this is also not the complete machine code, right? So it is also containing words like leave, right? And you can see here, so these are the words it is using now, right? So this is also not the completely machine code, but the compiler transformed from the source program to the assembly code. So now we will till now we have discussed about the compiler. It is a translator type, right? So this one is completed. Now we will discuss about the second type, that is interpreter. So this interpreter will also do the same thing. It takes as a program that reads a program and written in the source language and translated to an equivalent target language by line. You can see here line by line. So note this, line by line. You can see the source program here. It is like C, C++ or Java, anything. It is also transformed from high level language to low level language, same like compiler only, but only the one difference is here it converts the line by line. Suppose we will take one statement like int a equals to 10, okay, and int b equals to 20 and int c equals to a plus b, okay. This is some source program, okay. If it is a compiler, suppose take it here compiler, what the compiler will do is it will transform entire program at one pass, like it transform entire thing at one time, and it will generate the target program for assembly language. It will generate for the same thing, it will generate the low level language like assembly language, it will generate here, right? So that is compiler. But take the interpreter, what it will do. So take the interpreter, it will do like it will transform first this statement, it will transform to assembly language, next it will transform to assembly language. If any errors are there from converting this statement to assembly language, then immediately it will throw that error message. But in the compiler, after translating everything, if any errors are there, then only it will generate the error message. But in the interpreter, what it will do, it will generate line by line. Here also it will generate line by line. So that is the main difference between the compiler and the interpreter. Both will generate the high level language to low level language, but the difference is the compiler will generate at one pass and the interpreter will take line by line, okay. So these are the differences between the compiler and interpreter. I already told you that it scans the entire program at once and it scans that line by line at one time. It will one statement at a time, okay. And the error is also displayed after entire program is checked, and the error is displayed for every instruction interpreted, okay. And it generates the intermediate code and it does not generate the intermediate code. We will talk this intermediate code later, then you can understand, okay. And the memory requirement is more because we are taking entire program at once and we are storing this entire program, right? In order to check the errors, first we need to store this program. So that's why the memory requirement is more here. But here the memory requirement is less. Why? Because we are taking the line by line. So that's why here the memory requirement is less, right? And the example is C compiler. We already talked about it. And for interpreter, the basic Python, Ruby, right? The Java is also having Java interpreter, separate Java interpreter is there, right? So till now we have discussed what is a compiler and what is a interpreter. I'm thinking that you understand what is a compiler and what is a interpreter. So the third type is assembler, and we will discuss that one in later part. So okay, So first we have discussed the compiler and the interpreter. Now the compiler, you know that it will take one source program and it will generate target program, right? So how it is generating, how it is transforming, there is no magic here, right? So something process should be there, right? So that process is divided into two parts. So from here to here there is some process. That process is divided into two parts. That part is analysis and second part is synthesis phase. So in the analysis phase, what we will do, we will decompose the source program into intermediate representations. Okay, we will the source program, whatever we are taking as input, we will divide that source program or decompose that source program into some form that is intermediate representation. Okay, and now this intermediate representation will be the input for the synthesis phase. Whatever the output we are getting here in the analysis phase, that is the input to the synthesis phase, and this synthesis phase will be like, it will generate the target program generation from the representation. The representation is we have taken from the analysis phase, right? So we will see how it is going, what are the things included here, but the entire process is divided into two phases. One is analysis phase and then the other one is a synthesis phase. Okay, we will discuss both in this class. So this is the entire model. I am taking the source program as an input and I am giving the source program to the analysis phase, which is the first phase. I already told you the entire phases is divided into two phases. One is analysis phase, second one is synthesis phase. So we will give the source program to the analysis phase. It will divide the program and it will generate some intermediate representation, and this intermediate representation will be go to the synthesis phase, and the synthesis phase transform to the target program. Okay, so this is the entire model. Okay, now we will move to the phases. I told you that there are two phases. One is analysis, second one is synthesis. So in this analysis phase we are having three phases: lexical analysis, syntax analysis and semantic analysis. So these three phases are in the analysis phase, and in the synthesis phase we are having intermediate code generation, code optimization and code generation. So these three comes under analysis phase and these three comes under synthesis phase. And the symbol table and error handler, while we are going through each phase, whatever we are taking as a source program, we will talk about later when we are talking about the lexical analysis. Then you can understand symbol table manager. It will store the variables that are going through each phase, and it will store the errors that are going occurred in the each phase, and it will store error handler will store the errors here. So that is the main purpose. Okay, and I already told you that there are three phases in the analysis, that is lexical analysis, syntax analysis, semantic analysis. For the syntax analysis there is separate name, that is hierarchical analysis also. So in the lexical analysis what we do is, so this is the first phase in the compiler, right? So the source program will go to the lexical analysis. Don't confuse between the model and the phases. So we are having two phases in model, that is analysis and synthesis. So under analysis we are having again three phases. Those are lexical analysis, hierarchical analysis, semantic analysis. So the first phase we are having is the lexical analysis. What it will do is, it will scan the entire program. It will scan the statements, each statement in the source program, and it will convert that statements into the sequence of tokens. A token here, sequence of tokens. So the token is nothing but is a sequence of characters having the collective meaning, right? So the output of the lexical analysis is a collection of the tokens, right? And in the hierarchical analysis, what we do is whatever tokens we are getting here, so we will do that, we will